solving quadratic equations with factoring. So we're still solving quadratic equations. Now we're going to look at the method where we factor the quadratic equation and then use that to solve for the unknown. So here we have just a list of steps to take. First of all, we need to move all of the terms of our quadratic to one side. So let's do that for our example. So x squared plus 3x, and we're equal to -2, so if we add 2 to both sides, then we're going to get x squared plus 3x plus 2, and then that's going to be equal to a 0, right? Because if we add 2 to -2, we get 0. Okay, so that gives us step 1. Now, step 2 is where we want to factor. We've got a quadratic with leading coefficient of 1. So that means in that first position, we're going to have x and x. And in the second position, we want the two integers that multiply to 2 and add to 3. So that's going to be a plus 2 plus 1. All right, so that takes care of step 2. Step 3, we've got two factors here, x plus 2 and x plus 1. They're multiplied together and equal 0. And we've got the property that says that if you have a product equal to 0, then the individual factors can be set to 0. So we take x plus 2 equal to 0, x plus 1 equal to 0. We have two simple linear equations. In step 4, we're going to solve those for x. So subtract 2 from both sides. We get x equals -2, and then x equals -1. So those are our solutions to the quadratic equation. Okay, let's look at this quadratic equation. We've got 6x squared plus 2x minus 4 equals 0. All terms are on one side and it's 0 on the other. So step 1 is taken care of. For step 2 here, we want to factor. Now, first thing I notice is that there is a greatest common factor of 2. So first thing we're going to do is factor that out. So we'll bring a 2 out. That leaves us in parentheses 3x squared plus x minus 2 equals 0. Now you might wonder, well, what do we do with that 2 that's out in front? Well, we can sort of think about dividing both sides by that 2. And that cancels it on the left. And on the right, we just have 0 over 2. Well, any time we have 0 over a number, but except for 0. So if we have 0 over any non-zero number, that's just equal to 0. So we end up with the quadratic 3x squared plus x minus 2 equals 0. So now we want to factor. And here we want to factor by grouping because we have that leading coefficient is 3. It's not equal to 1. So we got to remember how we factor by grouping. So first thing is we take the 3 and the -2, multiply those together. We get a -6. And now we want the two numbers that are going to multiply to get a -6, while at the same time they add to the coefficient on the x term. So the coefficient on the x term is a 1. Okay. Well, it turns out this time around it is the same two numbers that we multiply to get that -6 in the first place, right? To get -6 by multiplying, we're going to take 3 times -2. Well, if we add those together, we also get a 1. Okay, so now what do we do with those two numbers that we came up with? We replace the middle term, that x term, with two x terms with a 3 as a coefficient and a -2 as a coefficient. Right, and then we've got the -2. All right, so this, the 3, we now have a 3x, and for the -2, we now have a -2x. Here's where we come up with the grouping part. So you group the first two terms together, the second set of two terms together, and we factor them individually. So we look at the 3x squared plus 3x. Okay, we've got greatest common factor of 3x, that comes out in front, and inside parentheses, we're left with an x, and we're left with a plus 1. And we look at the second grouping. The greatest common factor there is a negative 2. And what we're left with from on the inside is we're going to be left with an x and a plus 1, which is what we would have expected because we want to have that same linear factor show up in both groups. Okay, so that linear factor comes out in front, so we get that x plus 1. And then we write down what we have left over. So we've got a 3x here and a minus 2x here. So our other factor is 3x minus 2. All right, and that's equal to 0. Okay, so we have factored. Now we go on to step 3, which is where we're going to take these factors, set them equal to 0. We have two simple linear equations that we can solve for x. We get x equals a negative 1. And here we're going to first off get 3x equals 2. We divide both sides by 3. And we end up with, oops, we don't want that 3. We want x equal to 2/3. So we've got two solutions, x equals negative 1, x equals 2/3. Let's look at this one. 5x squared minus 14x minus 3 equals 0. All the terms are on the same side. So second step here is going to be to factor. Leading coefficient is 5. It's not equal to 1. So we're going to factor by grouping again. So to do that, we take 5, the coefficient on the x squared term, multiply that by the constant negative 3, and that gives us a negative 15. So with that negative 15 now, we want two numbers that multiply to negative 15, and then at the same time, we want them to add to negative 14. The two numbers we multiplied originally to get negative 15, 5 and negative 3, are not going to add to negative 14. So we got to come up with other numbers. So let's try negative 15 and a positive 1. That adds to negative 14. So those are the two numbers that we're going to want to use. So we're going to rewrite our quadratic. We keep the 5x squared. We replace the negative 14x with negative 15x plus 1x, or just x. And then we got minus 3 equals 0. All right, so we can see that if we just combined those two x terms, negative 15x plus x, we would get back to the negative 14x we had originally. Okay, here is where we do the grouping. We're going to group these first two terms and the second two terms, or the second set of two terms. And now we factor out the greatest common factor from each of those groups. So from the first group, we've got greatest common factor of 5x. We bring that out in front, and now we want to write down what's left over. Well, if we divide 5x squared by 5x, we're left with an x. If we divide negative 15x by 5x, we're left with a negative 3. We go to the second group. Well, it doesn't look like there's any greatest common factor, but we always have a factor of 1. Every single expression or number shares a factor of 1. So we can bring out a 1. And then what are we left with? We're left with x minus 3. Okay, we ended up with what we would have expected. We've got this linear factor from both groups of x minus 3. We bring that out in front. And then we have another factor that's going to be what's left over, and that is a 5x. And then here's where that plus 1 is going to show up, 5x plus 1. That equals 0. All right, so just a reminder where those come from. They're just what's left over after we factor out that linear factor of x minus 3. All right, that gets us through the factoring. Now we have two linear factors. We can do step 3. And set those both equal to 0. X minus 3 equals 0. 5x plus 1 equals 0. And solving those give us our solution. X equals 3. And 5x equals negative 1. Divide both sides by 5. So we end up with x equals negative 1/5.